Assalamualaikum and hi sir. We are group 1 from DKM 5A. We are going to do the case study part 2 for the subject DJJ 6132 Engineering Plan Technology with the title of Use of Steam and Layout of Steam Power Plant. We are consist of 5 students. The first one is Muhammad Wahiduzaman Fatihi bin Wahid with the metric number 01 DKM 16F 2029. This next one is Amir Izam bin Muhammad Zamri with the metric number 01 DKM 17F 1071. The third one is An-Nur Fatihah binti Muhammad Rizal with metric number 01 DKM 18F 1001. The fourth one is Ummu Aiman binti Muhammad Azhar with the metric number 01 DKN 18F 1002. And the last one is me, Muhammad Hazim bin Mazlan, 01 DKM 18F 1003.
Assalamualaikum warahmatullahi wabarakatuh. My name is Amir Izam bin Muhammad Zamri. My metric number is 01 DKN 17F1071. I will continue about the case study on part 2. Question A. A standard diesel cycle is an idealized cycle for diesel engines. Sketch a PV and TS diagram and clarify 4 different processes for the ideal diesel cycle. Here is the PV diagram and this is the TS diagram. PV diagram is stand for the pressure over volume diagram and TS is stand for the temperature entropy diagram. Clarify 4 different processes. In diesel engine, there are 4 different processes, which is number 1, the intake stroke, number 2, the compression stroke, number 3, the power stroke, and the 4th is the exhaust stroke. So for the PV diagram, on intake stroke until the compression stroke, the volume the volume is constant with the pressure. That is called isentropic compression from 1 until 2. From 2 until 3 is the constant pressure heat addition. Is this when the pressure is high on the 2 and 3 because the piston is creating pressure in the cylinder. Q is stand for the heat were added when the compression. And from 3 to 4 is isentropic expansion, is when the heat is constant with the volume decreasing because the volume will out and from the compression state into the exhaust state. This is why it was decreasing. And from 4 to 1 is the constant volume heat rejection. Constant volume heat rejection is when the heat will reject into the surrounding and will cool down. This is when the Q is out, meaning that the heat will reject into the surrounding. For the TS diagram is the temperature entropy. This is where the heat is on the peak and the cool down is on the bottom. So from the intake stroke until the compression stroke, the heat will maintain on the same temperature. From 2 and to 3, when the power stroke, the heat will added. This is why it called constant pressure heat addition, as the compression were adding heat until the power stroke. And when the power stroke, the mix and fuel were burned, it was isentropic expansion, as the heat were constant with the volume. As the volume were decreasing, the heat also decreasing until so from the 4 until 1 is the constant volume heat rejection. They were cooling down, so the heat were out and until the surrounding. Question B. Assemble with construct a block diagram that show how the diesel engine starting system works in diesel power plant. This is the schematic diagram of diesel power plant. Diesel power plant consists of fuel, air, the engine, exhaust, and this power plant also with addition of cooling tower and oil cooler. So to start the engine system, the fuel and the oil and this is the fuel, oil and the air going into this power plant through the pump, and the air will compress into the plant, and this is where the fuel is where the mix of air and fuel from the tank and goes into the injector, and the injector goes into the engine. So when the diesel power plant run a 4 cycle, the extra gas will into the exhaust system, which is the silencer here, and the energy from the work running the generator at here and create electricity. And this is the cooling water system. So from the engine, the cooling water system will go into the heat exchanger and into the cooling tower. The heat exchanger over here is because the water from the cooling tower has extra cold, and the heat exchanger will decrease the extra cold into the cold that's suitable for the engine. So from the cooling tower into the heat exchanger into the oil cooler, this is where the lubricating oil into the engine that remove the friction of the engine goes into the oil cooler, and this is where the oil from the engine will cool and goes back into the engine. That's all from me. Thank you.
Assalamualaikum. My name is Muhammad Wahiduzaman Fathi bin Wahid. I'm going to answer the question C. Sketch the layout of basic compressed air plant. So, a modern industrial compressed air system is composed of several subsystems and many subcomponents. First, the compressor is the mechanical device that takes in ambient air and increase its pressure, and the prime mover powers the compressor, controls the serve to regulate the amount of compressed air being produced. Treatment equipment removes contaminants from the compressed air, and accessories keep the system operating properly. Distribution systems are analogous to writing in the electrical world. They transport compressed air to where it is needed, and the compressed air storage can also serve to improve systems performance and efficiency.
Assalamualaikum and hi sir. My name is Muhammad Hazim and I will continue with question D. A positive displacement pump can be classified according to rotary and reciprocating type. What is the category of load pump? Sketch a load pump by showing the liquid flow, direction, insertion, discharge, and blade. This is example of load pump. Category of load pump. Load pump is a type of positive displacement pump. The way that the pump operates is liquid that taken from one end and positively discharged at the other end of every revolution. Positive displacement pump are widely used in industrial and commercial for pumping the liquid other than water, such as thick liquid oil. This because load pump has high efficiency and corrosion resistance. It also has typical speed of about 100 to 500 RPM. Other than that, load pump also used in food industry and biopharmaceutical processing. This makes sense because the rubber part in this pump is easily to sanitize. A load pump is a rotary pump that is under the type of positive displacement pump. Rotary pump is a valveless pump in which the fluid is positively pushed by machine vane and parallel revolving shaft and machine screw into the discharge pipe. It is similar to the gear pump, except this pump designed to almost meet rather than touch and turn each other. This is a working principle of load pump. I will explain how the load pump works. Load pump is similar to the external gear pump in operation in that fluid flow around the interior of the casing. Unlike external gear pump, however, the load pump is not make contact. The contact is prevented by external timing gear located in the gearbox. Pump shaft support bearing are located in the gearbox, and since the bearing are out of the pump liquid pressure is limited by bearing location and shaft deflection. From the picture number 1, as the lobe come out the mesh, they create expanding volume on the inlet side of the pump. Liquid flow into the cavity and is trapped by the lobe as they rotate. The next one is liquid travel around the interior of the casing in the pocket between the lobe and the casing. It does not pass between the lobe. And the third one is finally the meshing is of the lobe force liquid through the outlet port under pressure.
Question E. Vane pump is a rotary type. Illustrate a vane pump by showing the liquid flow direction, inlet, outlet, rotor and vanes. First, a slot rotor is eccentrically supported in cycloidal cam. The rotor is located close to the wall of the cam, so a crescent-shaped cavity is formed. The rotor is sealed into the cam by two side plates. Vanes or blade fit within the slots of the impeller. As the rotor rotates and fluid enter the pump, centrifugal force, hydraulic pressure push the vanes to the wall of the housing. The tight seal among the vanes, rotor, cam, and side plate is the key to the good suction characteristic common to the vane pumping principle. The housing and cam force fluid into the pumping chamber through holes in the cam. Fluid enters the pocket created by the vanes, rotor, cam, and side plate. As the rotor continues around, the vanes sweep the fluid to the opposite side of the crescent, where it is squeezed through discharge holes of the cam. As the vane approaches the point of the crescent, fluid then exits the discharge port.